Okay, here we are, mathematicians, taking a look at how to factor an expression. So this is Chapter 6, Lesson 6, Part 2. So your book needs to be open to page 487 as we get started. So I'm going to move this up here, and we're going to go ahead and get moving. So taking a look at factoring an expression. Now, here is the thing about this. I don't really like to do the prime factorization. So I'm going to teach you a different method rather than doing prime factorization. I will go ahead and show you one example, basically off of this example, how to use this method should you choose to use it. But then I'm going to refer to a different method that I think is easier, but it's still good to see this in case it says that you might have a question where you might have to answer the problem two ways. So I'll show you this way when we're learning how to factor an expression. So here it says factor 12 plus 8. What you need to do is you need to write the prime factorization of 12 and 8. So how does that work? It looks something like this. I'm going to take the number 12 and I'm going to break it down into two numbers that I can multiply together to get 12. Well, I know that 2 times 6 gives me 12. Okay, when I look at 2 and 6, I know that 2 is prime, so I'm going to go ahead and circle that. Then I look at 6 and I'm going to break that down to 2 and 3. I know that 2 is prime and I know that 3 is prime. Therefore, I am now done because I have no other composite numbers to break down. So the prime factorization for 12 is 2 times 2 times 3. Again, I'm going to show you two ways. This way is a little bit harder. Not necessarily harder, but it's just maybe more work. So now what we're going to do is we are going to go ahead and prime factor 8. So I'm going to take 8 and we are going to break it down into two numbers that we can multiply together to get 8. So we're going to take 2 times 4. I know that 2 is prime, meaning it's only one in itself, but I know that 4 can be broken down into 2 times 2. So the prime factorization for 8 is 2 times 2 times 2. Now what you do is you then see what numbers they have in common. So I see that they share a 2, so each of them have a 2, and they have another 2. Now you see that one has a 2 and one has a 3, so we're not going to line those up. So now what we do is we multiply the numbers they have in common. So 2 times 2 is 4, which means that is the number that we are going to take out. Okay? So now when I look at 8 and 12, so over here, I'm going to look at 8 and 12, and we are going to factor it. We are going to take out that 4, and then I look at what is left. So I'm going to go at 8, and I know that, or 12, I guess it was 12. Let me flip this around because it was really 12 plus 8, not that it matters. But I know that 4 times 3 is what we're going to put in parentheses, plus 4 times what gives me 8? 4 times 2. So when we factor this expression, we get 4 and then in parentheses 3 plus 2. Now I'm going to show you another method that I actually prefer. And it's kind of, there's no really technical term for it. It's kind of like upside down division in a way, but we are going to pull out the greatest common factor. Here's another reason why I like this, because greatest common factor, factor the expression. Okay, obviously they share the same word, so there's got to be some meaning behind it. So let's just take a look. Just watch. So I'm going to put 9 plus 21, and then I'm going to do like the upside down division sign. When I look at 9 and 21, I have to think of what is the greatest common factor. Now, you should probably have the factor sheet, so you can use that, or knowing that these numbers are small enough, you might already know what the greatest common factor is of 9 and 21. Well, I know that it's 3. Okay? So now I'm going to come down here and I'm going to say 3 times what gives me 9? 3 times 3. Plus, then I'm going to go 3 times what gives me 21, and I'm going to put that down here, 7. Now I have 3 and 7. I want to make sure that I cannot take out any other number, meaning that those numbers don't have a common factor. So 3 and 7, the only common factor that they have is 1. And if I take out a 1, I'm still going to be left with 3 plus 7. So we're going to leave it how it is. Now, what happens is our greatest common factor is on the outside of our parentheses, and then what we have left down here goes into our parentheses. Now, how can we check to see if this is correct? Easy. We're going to do distributive property. We're just checking. This is my answer right here. I'm just checking. 3 times 3 is 9, and then 3 times 7 is 21, which means we did it correctly. Okay, let's move on. Oops,
let's move on to the next one, maybe, if I can get this back up. There we go. Okay, let's move on to the next one. So I have 14 plus 28. Okay, I got to think of what is the greatest common factor of 14 and 28. When I look at this, my first instinct is to think 7. Okay, watch what happens when I do pick 7. I know that I'm left with 2, and then 7 times what gives me 28, 7 times 4. But now look at 2 and 4. They share a common factor other than 1. They share 2, which means I do not have the right answer here. Okay, so I'm going to go ahead and erase this, knowing that I need to change my answer. Maybe if it's going to erase. Okay, I need to change my answer, and I know it's got to be higher than 7. I know that it is 14. So 14 times 1 gives me 14, and 14 times 2 gives me 28, which means I'm left with 14. Bring this down here, and then in parentheses, what is left over? 1 plus 2. Okay? Now I'm going to go ahead and move on, and I'm going to go ahead and take a look at 80 plus 56. When I look at 80 plus 56, I know that the greatest common factor of both of those numbers is 8. So now 8 times 80 is 10, plus 8 times what gives me 56? 8 times 7. Now looking at 10 and 7, do they have another common factor that is greater than 1? Nope, just 1. So I know that the answer is 8 in parentheses 10 plus 7. Okay, let's turn to the next page and do some more examples. So we're going to go to, I got to go this way. There we go. We're going to take a look at this. Now what we're going to do is we're still going to factor, but we're going to bring in the value of a variable. Okay, so nothing really changes. I just want you to watch this one. If I have 16 plus 4x, the greatest common factor of 16 and 4 is 4. Okay, so 4 times what gives me 16? 4 times 4 plus 4 times what gives me 4x? Well, it's just 1x, or I can just put x. So watch what happens. I'm left with 4 plus x. Now let's check to see if that will work, and we get back to our original problem. So, back to our original problem. So 4 times 4 is 16. 4 times 4x is 4x. So we know that we did it correctly. Okay, let's take a look at I. So I have 7x plus 42. I know that the greatest common factor is 7. 7 times 7x is x, plus 7 times what is 42? It is 6. So now I know that I can't take anything else out from there. I'm left with 7x plus 6. Okay, and then let's take a look at m. So we have 36x plus 30. Finding the greatest common factor of 36 and 30 is 6. I'm left with 6x plus 6 times what is 30? Times 5. I know that the greatest common factor of 5 and 6 is 1, so I believe that I'm done, but I'm going to write it down. 6x plus 5 in parentheses. Now let's just check it. 6 times 6x is 36x. That's good. 6 times 5 is 30, and we know that we did it correctly. All right, let's jump down here and let's do these two problems. All right, it says factor each expression. So here we go. We've got 25 plus 60. I'm going to take out the greatest common factor of 25 and 60, which is 5. So 5 times what gives me 25? That's 5. 5 times what gives me 60? That's 12. When I look at 5 and 12, I know that I cannot multiply or I cannot take out a greater common factor other than 1. So we know we're finished. So I'm left with 5 in parentheses, 5 plus 12. All right, last one. So here we go. We're going to do this plus 40. I'm going to write it upside down. I know that we're going to have 4. Okay, 4 times what gives me 4x? X. 4 times what gives me 40? 10. So when I write this, I'm left with 4x plus 10. Okay. All right, I think that we are done for today on the factoring expressions. If you have any questions, again, you saw two ways to do it. You saw this prime factorization. Okay, that's way number one. And then you saw a whole bunch of different ways of doing like upside down division. Basically, it's kind of like working with area models, because you could just put this in an area model and pull out the greatest common factor. So you guys are doing awesome. Keep it up.